All right, thanks a lot, guys. My name's Matt. I'm the head of engineering at a company called Shapeways, and I'm here today to talk to you guys a little bit about a story of our journey from basically not knowing how to release software quite at all to implementing continuous integration, and then right up to the point of actually having release when ready, where we deploy multiple times a day, basically whenever the developers are ready to have code, and sort of the steps we've taken along the way to get there, some of the pitfalls we ran into, and hopefully that you can avoid doing the same. So to get started, we'll talk a little bit very quickly about what Shapeways is. So Shapeways, for those of you who haven't heard of us, is a 3D printing marketplace service where you can upload 3D model files that either you've created and purchased them, one of 50 different materials or finishes, or you can actually offer them for sale and allow other people to purchase them. So by nature of that, when we first started, we were indeed a web-only company where everything was on the website. So we have marketplace, community, service hub, everything's hosted at shapeways.com. And then as we matured, we implemented a REST API starting in 2012 at api.shapeways.com, which basically is designed to do the exact same things to enable people who are more technically savvy, who want to run their own businesses and own their own brands to do so on their own platforms and use us as a manufacturing partner. So that's enough about Shapeways. Just wanted to give you guys a quick intro so you can have some context for what we're talking about here. So why would you go about implementing continuous integration or continuous delivery? And I'd say you should take a look at the software development lifecycle. There's a number of different ways to represent this, but the basic one here, where you take an idea and then you bring it into execution and evaluation and continue to iterate on that idea. Along the way, you have exploration, you have definition, you have the execution, actually writing the code, and then you have the release and the evaluation, making sure that it met your business goals, move the needles in the most appropriate way, and if not, we either abandon it or continue to iterate. And every stage represented up here on the board requires active, valuable work by software team members, whether they're product managers, UX designers, business stakeholders, developers, front end or back end. They're all required to do their very specific tasks to make sure that this process goes forward correctly, except this text right here. Release. Release tends to be a very manual process, a scriptable process, but a manual one nonetheless, which requires mechanical work, pulling code, updating libraries, restarting services. Not something that is necessarily the best use of a software engineer's time. Now, when you release software, it starts pretty easy. You have one small web server. You go to the web server, pull down your code, restart services. If everything's working, site's up, API's working, everything's turning 200s, you have margaritas. That's great. Or you even go one step simpler than that, and you use one of these great services that exist out there, like Heroku, who actually manages all your deployments for you based off of your source control. So you don't have to worry about any of it. It just happens for you, and that works great when you're at a reasonably getting started scale. But as you start to scale up, releasing software becomes a bit more difficult. You end up getting multiple stages in your deployment, starting with Git pulls, of course, but then you have to maybe build your front end if you're hosting a website. You have to manage your symlinks, restart services like Memcache or Apache, update your docs, whether it's off of an automatically generated thing, or just actually physically remembering to update your documentation as you go. At this point, release starts to become more than just a simple source control operation. Now you actually have a certain number of steps that have to be followed in a specific order in order to make things function on the other side. And this sort of creates two situations. The first one is that it requires people to have very specific knowledge of how to do this. Anyone who's a software developer knows how to do a git pull, SVN up, whatever you're happening to use for source control. Anyone can do that. But remembering which services to go to, which servers everything's running on, how to restart them, requires some specialized knowledge that's to be trained into people on the team. And what that generally leads to, and I can say firsthand has led to at Shapeways, is only a small number of people actually bothered to learn this, and those people are the ones who end up becoming responsible for deploying software to the websites. So when that happens, you then got a scoped scale, or scoped number of people who can't go on vacation, can't get sick, can't leave the company. If they do, you have to find new people to help you out. The first couple times you do it, you might make some mistakes, and then boom, you have problems with your release. And now, this gets really hard when you start to have global scale for your web services or your APIs. So you have to generate artifacts, run continuous integration jobs on them, make sure that code's generated, make sure that templates are built, deploy to multiple data centers, handle deployments inside of your data centers, restart your services, manage your symlinks in case you have old versions of your code, and so on and so forth. And this can get as complicated as you can pretty much imagine. And deployments like this, especially if they're done manually, and even if they are done with a script, take time and resources. Sometimes they have dedicated team members. Sometimes they'll have an actual hour of someone just tending and monitoring how this thing goes. And if you're not careful as you try to scale this up, you'll spend as much time running deployments as you do actually writing code and delivering things that your users actually need. Again, we've been there. So what I'm hoping to tell you guys today is a little bit of the story about how we got where we were, where we are today, how we got there, and what we're hoping to see coming forward. So to start in the beginning, these were 3 things that were factually true about Shapeways when I first joined the company. Not that I'm the one who fixed everything or even anything, but this was the case. So when we joined the company, we had 60-minute deployments to 3 web servers. And the cause for this was that we had one very, very, very tiny SVN. We were on SVN at the time, host, which we still have today in our repertoire of servers. That had about a gig of RAM, and then when everything would try to pull the entire repository down from it, you'd flood it. It would take forever. It would slow down. We also had distributed services in AWS for our model processing, which is a fancy way of saying the piece of software that we've written to ensure that models are printable. We scale it in and out of the cloud because it's nice that way. You actually scale compute the way it's intended. And that also had to pull down old copies of the code. So we would saturate the server, take forever to restart services, take 60 minutes to put code to the website. We had 0 API documentation. At the time, we had a SOAP API that we had implemented for 2 clients, and then we would sort of onboard people as they were interested and expressed interest in the Shapeways API. But all of this was internally maintained on an internal Confluence server, and we would basically give people access. The docs were therefore woefully out of date, and we had no actual testing on the API at all. And for the web component, we actually had frustrating manual testing, which was run largely by product team members, UX designers, and then also engineers when it was possible. So we had unit tests, which was good. They were run by developers when they remembered. But again, code was just pulled, yeah, laugh, I know. And then code was just pulled onto the web servers, and we hoped for the best on restart. We ran releases every 2 weeks, and I'd say 1 out of 4 brought the website down due to either bad practices, not enough people doing the job that they had to do, or just a little bit of a lack of diligence when it came to working through their software prior to release. So from there, we took some baby steps. So the first thing we did is we brought in Jenkins for continuous integration. For those of you who don't know Jenkins, it's one of many excellent continuous integration server options. It's the one we happen to choose. We set up proper CI on it, which basically mirrored our developer branch, where we would basically was our staging for release. And every time someone would commit to that, we'd fire off a run of the unit tests and actually build an artifact. And the purpose of the artifact generation was that we would have a single piece of code that ensured that every piece of code that we tested was then exactly what went live to the website. That artifact could be deployed to QA servers, could be deployed to beta servers, then to production servers as a unique piece. And it never changed along the way, so you had no possibility of changing the code that you were testing before it went live. So this already helped just basically by ensuring that the unit test that we wrote got run, which caused a ton of bugs. And that right away solved a lot of our release problem in terms of breaking the website when it went live. The next thing we did was we wrote integrated and functional testing with both Selenium WebDriver for the web and Python requests for testing the API side of things. And that got us sort of 2 things. The first one is that the functional testing obviously tested the website, made sure that things like user flows, checkout, model upload, all of these things went correctly. And it also enabled us to pair that same level of testing against our API. And this is when we really started treating our API as a first-class citizen inside of Shapeways instead of something that was sitting down in steerage. And this enabled us to, this has become the biggest growing platform that we have on Shapeways.com for bringing new business on board. So treating it in such a way and giving it the respect that it deserved helped us get to a point where we're actually a company that could say, hey, we have an API and you can use it, as opposed to we have an API, please don't ask too much. And then the third thing, which is kind of a simple one, is that we require new tests to be submitted with features when they were shipped. Both unit and functional or integration, depending on where the code change happened. On the unit testing side, this just continued to give us better coverage. And on the functional integration testing, it helped us both build our suite of tests, and then it also helped us prevent regression as we went on going forward, because we had these integration and functional tests running at the time hourly on our Jenkins server against our QA hosts. So as these tests ran every hour and the test suite grew, you had more and more protection against regression going forward with releases, which gave us more confidence for releases, which then made us feel like, now it's time we can go down to a release every week. And that worked. Then it became a release every 2 days, and then it became a release every day. And that was awesome. We got to that point, but it still required a pretty significant amount of work from a quality team member. And when we say a quality team at Shapeways, what we're talking about is actually a team of software engineers who are dedicated to building test infrastructure and internal tools to make sure that build, release, and deploy all go well. So those team members, it's a small team, maybe 3 or 4 people at any given time, had started to feel the pressure, and they were spending all of their time writing tests, running tests, and doing deploys for the rest of the developers. So at this point, we decided it was time to pro up a little bit. So the first thing we did with that was take a look at our utilization of Jenkins. Before, we hosted Jenkins on a small desktop PC under my desk in our office. That was fine, it worked, but it had its fair share of problems, like sometimes I had to turn it off. So what we ended up doing is actually installing active Jenkins instances in our 2 data centers that we have today. This setup will scale, and each of those instances become responsible then for deploying the entire data center worth of servers, whether they're model processing or development or any one of our services or APIs that we provide underneath. This abstracts away the need for developers to understand exactly what happens inside of each DC. They can just say, hey, Jenkins, deploy this data center, and it knows, based on its own configuration, where to go, where to put the code, how to get it, and all of that. We also started leveraging the Jenkins API for this. Jenkins is a very great API, very simple for doing this sort of work, with security as well. So no one's just randomly deploying code to our data centers. It's all internally VPN'd as well. But what this lets us do is permit remote code execution and deploy jobs to run from anywhere. It doesn't have to run from the data center itself. We can kick it off like from my phone, for example, which we did at a board meeting once, which was funny. And then we also used the Jenkins flow pipelines, which is a feature of Jenkins 2.0 that they've onboarded naturally based on the massive demand from users, where you basically can use their own domain language to define flows for your particular jobs and chain them together, which allows you to actually treat your Jenkins jobs like software. You develop generic patterns, you move forward, and you use them and implement them where they so belong. So you don't have to write a whole bunch of repeated scripts over and over again. Next thing we did was we created a piece of software called Coyote Framework. And to explain why the Coyote, our custom PHP framework that we use to write our website and our API is called Roadrunner. So we stuck with the theme, figured that the testing framework that would be chasing the production framework should be called Coyote. It's an in-house open source testing framework for both the integration and functional testing that I described earlier. It very heavily leverages Selenium WebDriver and Python requests. And our goal in writing this piece of software, which you can get, it's at the end of this presentation, it's on GitHub, was to basically have an infrastructure that allowed for consistent, reliable, and reusable and maintainable tests. So we followed the page object paradigm, which is definitely not invented at Shapeways, but it allows you to encapsulate single pages and single HTML elements as classes that you're interacted with. So the same is true for building up controllers on the API side of things. So this gave us the ability to do what we like to call 2-level API testing. The first is the integration level testing based on straight HTTP requests, so we can make sure that we're doing contract enforcement, that we're saying, okay, the API that we've agreed to build is being tested, is confirmed, we haven't broken it along the way. The second thing that allows us to do, especially with the Selenium integration, is to do flow testing, things like application creation for our APIs, revocation of permissions, adding accounts, testing full, sign up a new app, add it, check out, make sure that all these processes work correctly in our testing environments that we release to our users. We have very strong confidence that we'll be able to go forward. Another thing we did, again, sticking with the Coyote theme, or the Looney Tunes theme, I suppose, is we created a piece of software called Acme. And what this is an in-house developed test management application. And again, there are, since we have started this, a number of tools, including Jenkins itself, have created nice management interfaces for this kind of thing, where basically it has a little bit more than test intelligence. It has a little more test intelligence than your regular run a test, did it pass or fail. Inside of here, we keep historical test runs. We can figure out if a test is flaky or not, and we can also figure out whether or not the test that we've run has passed on master versus the branch we're working on, so we can more quickly identify failures. And tying this all together is a name that you've heard before, which is HughBot. We use HughBot inside of Slack to manage all of our deployment now. Instead of people having to remember which servers to deploy, which data centers to deploy, how to deploy them, we have a Slack channel. They can ask HughBot to deploy their code, and it will do it to production in under 5 minutes globally. And this HughBot basically ties together everything we talked about before, Coyote framework, Jenkins, Acme, into reusable components that are all contained in just one chat window that developers use. HughBot can do all kinds of things. He can spin up quality environments. He can deploy test environments, kick off test runs, report on performance metrics, code coverage. Basically, all of this comes out of the box with HughBot. You just have to write the integration for your own specific piece. So we've invested in that, and again, this is the final step in sort of taking us to the point where we can deploy now 10, 15, 20 times a day if we so choose. And then really quickly, just what we're looking at going forward. First thing, we're looking at our staged rollouts. Right now, we do a base deploy that just deploys everything. I think at this point, it's 25 or 30 web servers, all at once, all at the same time, restarting Apache as they go. That's great, but it doesn't let us fail traffic on and off and nodes in and out of the load balancer. So it is possible that during the Apache restarts, which are done gracefully, but it's still possible that during that restart, something might happen where a user would lose their session, an API would get disconnected, whatever. So we're trying to fail things in and out intelligently, and then also give small portions of our traffic over to new features as we launch them to see if, is their performance okay? Do people like it? Are they using it? We do that today. We accomplish this today via feature flags in our database, but if we could get this down to the infrastructure level instead of the app level, I think we can leverage HughBot once more to get things going and make sure that we get our testing done in that fashion. We've heard people talk about Swagger. We're looking at implementing that as well for all of our APIs, both our internal and our external ones, for all the reasons that you heard spoken about before. Client generation and updating, test generation and execution, and serving as a single source of truth, so we make sure that what we're building is exactly what we're shipping. And the last piece is around improved test tooling. So generating testing profiles based on changes made in our production application. We can use our URL mapping inside of our APIs to detect which controllers we're doing and actually create code coverage using our integration test as opposed to our unit test, which is not something that we've seen yet. So something we're working on actively, pretty excited going forward. And as soon as we have something on it, we'll share it with you. And that's what I've got. Thanks, everybody.